Okay, for this part of the lab, we're going to go over the cranial nerves, and then we'll get into the spinal cord, and we might get into the spinal nerves. So for the cranial nerves, you'll just need to know the cranial nerve name and number. So they're numbered using Roman numeral numberings. You have 12 cranial nerve, 12 pairs of cranial nerves that you need to know. They're numbered 1 through 12. Cranial nerve 1 is your olfactory nerve. Okay, up here. These kind of look like little weird hairbrushes. The nerve endings actually project down into the roof of your nasal cavity. We've kind of talked about that before. So to test for this is olfactory for your sense of smell. You just sniff aromatic substances. Okay, cranial nerve 2. This is your big optic nerve. You can just test this using an eye chart, one of those Snellen eye charts. It's got like the big E, and then the letters get smaller as you work down the chart. And cranial nerves 3, 4, and 6 all control extrinsic eye muscles. So you'll need to know that 3, 4, and 6 all control muscles that help move your eye. So cranial nerve 3, this is the oculomotor nerve. Then cranial nerve 4 is the trochlear nerve. Here, this only controls the superior oblique muscle of your eye. This muscle is actually kind of neat, the superior oblique. It actually kind of hooks through a little pulley and wraps around your eye. I'll try and show you a picture of that when we get back into visible body. And then cranial nerve 6, abducens, this innervates the lateral rectus muscle of the eye. So those two nerves only innervate one muscle each. If it's any other extrinsic eye muscle, then it's controlled or innervated by your oculomotor nerve. Okay, then back to cranial nerve 5, your trigeminal. Tri means 3. So you can actually, if you put 3 fingers up, it's called the turkey track because it kind of looks like a turkey foot. Put them against the side of your face, and you can actually follow the 3 branches of the trigeminal nerve. Okay, and then cranial nerve 7, your facial nerve. This controls things like taste, movement of your facial muscles. Then cranial nerve 8, your vestibulocochlear nerve. This used to be called your auditory nerve, but now it's the vestibulocochlear nerve because it controls hearing and balance and equilibrium. Okay, and then cranial nerve 9, glossopharyngeal nerve. It controls your gag and swallowing reflex, cough and speak, and it controls taste for the back of your tongue. And cranial nerve 10 is your vagus nerve. It actually controls a lot of your abdominal viscera, so it travels all the way from your brain, from your cranium, all the way down to innervate a lot of your abdominal organs. Then cranial nerve 11, your spinal or accessory nerve. This innervates your sternocleidomastoid and trapezius muscles. Then you have cranial nerve 12, your hypoglossal. This innervates that muscle that I told you to remember for when we got to the nervous system, that genioglossus muscle that helps you to stick out your tongue. Okay, now we're going to get into the spinal cord. I just went to the nervous system view and went to the first one. We're going to turn off the bones and the ligaments. Okay, so your spinal cord goes from your foramen magnum, okay, right at the base of your skull, all the way down to the first or second lumbar vertebrae. Okay, so to about right here. Let's zoom in. Okay, so right in here, we're actually going to hide the dura. Okay, so you can see that the spinal cord doesn't actually extend all the way down to the end of your vertebral canal. So at the end, it terminates right here, and this structure called the conus medullaris, so named because it looks like a cone. And then you still have spinal nerves that continue down your vertebral canal, and they're not housed in the spinal cord. They're just these spinal nerves. And so this is called the cauda equina because it looks like a horse's tail. And we're going to hide the dura right there. Okay, so it actually continues all the way down to your sacral region. And then here, if I can click on it, it's tiny. There we go. At the very bottom, you have an extension of your pia mater. The pia mater, remember, is that meningeal layer that clings tightly to the brain and to the spinal cord. And this is what actually anchors the spinal cord at the end to your coccyx. It's called the filum terminale. And this can actually be ripped out of place. It holds some tension on the spinal cord. So they check for this if you get into, say, a bad car accident and you have really bad whiplash. They want to make sure that this is still attached. Okay, you have enlargements of your spinal cord in your cervical and lumbar regions. These correspond to some plexuses that we'll talk about in a minute. You have 31 pairs of spinal nerves that arise from your spinal cord. Okay, you have, and this is kind of funky, so I'm going to actually have the dura there. But if you notice, you have 8 cervical spinal nerves. But if you remember, you only have 7 cervical vertebrae, and the spinal nerves are named for the vertebrae that is above where they exit, except for in the cervical region, they're named, the first spinal nerve actually exits above the first cervical vertebrae. And then you have C2, C3, C4, C5, C6, C7, and then C8 is where it exits below cervical vertebrae number 7. So from there down, all of the spinal nerves are named for the vertebrae that they exit below. So like T1, the first thoracic spinal nerve, exits below T1 vertebrae. Okay, and then T2, the second thoracic spinal nerve, exits below the T2 vertebrae. Okay, and then all the way down to your lumbar region, you have 5 lumbar vertebrae, 5 lumbar spinal nerves. They're each named for the vertebrae that they exit below. And then you have 5 sacral spinal nerves and then 1 coccygeal spinal nerve. Okay, so now we're going to look at the spinal cord itself. Let's see if we can actually go inside. Okay. So here you can see we have our spinal cord. This is the posterior side, so this is the back side of the spinal cord. This is the anterior side, so this is the front side of the spinal cord. The gray matter kind of looks like an H. I'm going to try to turn this without, oh, poop. And let me get it oriented. Okay, so the gray matter kind of looks like an H. Remember, gray matter and white matter. The gray matter are cell bodies and unmyelinated fibers. The white matter, these are all myelinated fiber tracts because myelin, that lipid insulating layer, is whitish, so that's why it's called white matter. Okay, so you have your posterior horns here. Here's a posterior horn, here's a posterior horn. These have interneurons and sensory fibers. These sensory fibers arrive from the dorsal root. Okay, so my view got messed up like 100 times. Today's just not my day. Okay, so here you can see here's a dorsal root. Okay, so when we talk about you have a dorsal root, and then you have a ventral root. Oh, right there. Okay, so these roots exit the spinal cord and they very quickly turn into your rami or your spinal nerve. Okay, spinal nerves are mixed. Okay, they contain motor and sensory fibers, but when you talk about the roots, okay, your dorsal root only has sensory fibers. Your ventral root only has motor fibers, okay? So when you talk about motor fibers, these motor fibers exit the spinal cord because they go to innervate our skeletal muscles, some glands. But these go to effectors. So these go, when you think motor, think movement, because all of this, these ventral fibers exit the spinal cord to go and innervate our skeletal muscles or sometimes glands. When you think about these dorsal roots, these are sensory roots. So when you think about perceiving a sensation like hot, cold, light touch, heavy pressure, okay, all of that information comes from the body to the spinal cord and then up to the brain. Okay, so if you look at the very bottom, I know I kind of jumped ahead a little bit. I see same Dave down there. Okay, that stands for sensory afferent motor efferent. Okay, and I just remember E for exit because efferent exits the spinal cord, and that's the motor fibers. Okay, they leave the spinal cord to go move something or go do something. And then the sensory, all of that comes toward the spinal cord. Okay, so that's all the afferent fibers. Okay, so now we'll look at the anterior horn. Let me see if I can mess this up again. Ooh, boop. It helps if you make sound effects. Okay, I think that's gonna have to be good enough. Okay, so there we go. So the anterior horns, okay, these horns on the front, okay, these contain the cell bodies for motor neurons. Okay, so this is for your voluntary system. So voluntary, the only thing that's under voluntary control in your body are your skeletal muscles. Okay, that's important to know. So these anterior horns send information out. Okay, remember same Dave. To the ventral root. Okay, so we've already kind of looked at these, but here's a ventral root. Okay, so this has information that's going to go out to your motor or your voluntary somatic skeletal muscles. And then we didn't talk about the dorsal root ganglion. A ganglion, I always think of like it's a gang, it's a cluster of bodies, okay, it's a cluster of cell bodies outside of the central nervous system. Okay, so you have a ganglion, this is a bunch of bunch of bodies, it's a big ganglion. Okay, wow, I kind of drove that into the ground. But remember, these roots don't last very long. They very quickly join together to make these spinal nerves, okay, or they called it rami. Okay, so all right, we will stop there and we will get into the spinal nerves and the plexuses.